In this second lesson on trigonometry, I want to focus on using those two identities that we derived last time from the unit circle. So that was sine squared x, or sine squared theta, plus cos squared theta equals 1, and also sine theta divided by cos theta equals tan theta. And I want to show you how we can use those to solve other problems or simplify other expressions. So I've got just a collection of expressions here. So this first one, well, remember that sine squared theta plus cos squared theta equals 1. Here I've got sine squared 3 theta plus cos squared 3 theta. So here, instead of a theta, I've just got 3 theta. It doesn't particularly matter what the angle is. If this and this are the same, then it's still going to sum to 1. So this actually does sum to just 1. B, 5 minus 5 sine squared theta. I'm going to factor out a 5, first of all, like that. And now if we rearrange this identity, 1 minus sine squared theta, that is equivalent to cos squared theta. So this is actually just 5 cos squared theta. This one here, C. So sine 2 theta over the square root of 1 minus sine squared 2 theta. Well, we've just used 1 minus sine squared theta equals cos squared theta. The bottom, we can also use this to help. Instead of theta, it will just be 2 theta. So it's going to be over the square root of cos squared theta. Sorry, cos squared 2 theta. It doesn't matter the fact that it's 2 theta or theta, it's just some angle. It just happens to be written as 2 theta. If we simplify that, we will get sine 2 theta over cos 2 theta, because we've square rooted cos squared. And then that is going to be equal to tan 2 theta, using our other identity that sine over cos is tan. Okay. All right, we'll have a look at some proofs as well. They might ask you to prove a result. So they've told you that these two statements are equivalent, and you've got to prove that that is true. Now, when you do this, you can either start with the left-hand side and try and rearrange it to get to the right, or you can start with the right and try and rearrange it to get to the left. But what's important is that you don't treat it like an equation, so you don't like keep the equals in and do things to both sides. You either start at the left or you start at the right and try and get to the other side. So I'm going to start with the left-hand side. So cos to the 4 theta minus sine to the 4 theta over cos squared theta. And we've got to try and rearrange it to 1 minus tan squared theta. The first thing that I've noticed here is the top follows a pattern of difference of two squares. Like when I've got x squared minus 9, I can factorize that to x plus 3, x minus 3. Okay, it's that sort of pattern, but it just happens I've got to the power of 4. So here I can rewrite this as cos squared theta minus sine squared theta multiplied by cos squared theta plus sine squared theta. And that is all over cos squared theta still. Okay. Now hopefully we notice something about that expression, and that is that it's got cos squared plus sine squared in, which we know is equal to 1. So that's just going to be cos squared theta minus sine squared theta over cos squared theta. Okay, because this bit here is just equivalent to 1. That was one of our identities. So we've got to there. We've got to try and get to 1 minus tan squared. Let's just separate this out. So I've got cos squared theta over cos squared theta minus sine squared theta over cos squared theta. And now hopefully we can see where our answer is going to come from. So this fraction is equal to 1, then this is going to be equal to tan squared theta. And that is our result, and we've proved it. So you might have to play with it a bit more than that. You might not be able to get it in your first try. Sometimes with these questions, you just have to sort of play around with it and see if you can get there. It might take you a couple of attempts to find the correct correct path through it. Okay, here's another question. Given that P is 3 cos theta and Q is 2 sine theta, show that 4p squared plus 9q squared equals 36. So what I'm going to do is I'm going to take those two values. So 4p squared, so that'd be 4 lots of 3 cos theta squared plus 9 lots of q squared, so that'd be 9 lots of 2 sine theta squared equals 36. And let's, well, I suppose I shouldn't write 36. Let's try and prove that it does equal 36. So this would be 4 times 9 cos squared theta plus 9 times 4 sine squared theta, which is then 36 cos squared theta plus 36 sine squared theta. Now what I could do is I could factor out the 36. Like that. And we then know that this bracket cos squared plus sine squared, that's one of our identities. That is just 1. So then we get to our desired answer of 36. Okay, I've got some more here. These are slightly trickier ones. Okay, let's look at A. We've got to prove that 1 over sine theta minus sine theta equals cos theta over tan theta. So I think I'm going to start at the left-hand side. And what I'm going to do is I think I'm going to try and combine these like I would add fractions. So I'm going to actually write them as the same denominator. You might not think this thing on the right is a fraction, but we can write it as a fraction. So this would be 1 over sine theta. Leave that one as it is. This one, we could write it as sine squared theta over sine theta. Because then they've got the same denominator. Sine squared divided by sine is just sine, so that works. Now I can combine this into 1 minus sine squared theta over sine theta. And 1 minus sine squared, remember that sine squared plus cos squared was 1. So 1 minus sine squared is going to give me cos squared. So this actually becomes cos squared theta over sine theta. Now the thing I'm aiming for is just cos over sine. So maybe if I rewrite this as, sorry, cos over tan is what I'm aiming for. So if I rewrite this as cos theta over sine theta, we know that sine over cos is tan. So that would mean that cos over sine is going to be 1 over tan. So here I've got cos theta over sine theta times cos theta. That's basically what this fraction is. Instead of cos over sine, I could write 1 over tan theta times cos theta, which then gets me to my desired result of cos theta over tan theta. Okay. So it might not always be obvious. That was definitely not an obvious one to do. Didn't necessarily feel natural to do some of those steps, but sometimes it is just a case of playing around and taking multiple attempts to see if you can get there. If you get stuck, then it's always a good idea to try and do it the other way around. Try and start at the right and get to the left if you get stuck doing it the other way. Okay, let's do B further down. Okay. So for question B, 1 minus sine theta over cos theta, and we've got to show that it's equivalent to cos over 1 plus sine. So let's just think of this as two separate fractions, I think. We'll start at the left-hand side again. So I'd have 1 over cos theta minus sine theta over cos theta. Maybe again, if we try and put these as like a common denominator. Yes, okay. Let's write this as cos theta over cos squared theta. The reason why I'm doing this is because I can see that I want to change my denominator to 1 plus sine theta. So I'm basically changing from cos to sine. So I want to try and really get a cos squared in there, because then I can use my cos squared and sine squared identity to change between sine and cos. So this other fraction would then be sine theta cos theta over cos squared theta. Then what I can do is I can change my denominator into terms of sine. So I can change this to cos theta over 1 minus sine squared theta. Like that. So then I can combine these into one fraction, cos theta minus sine theta cos theta, all over 1 minus sine squared theta. What can I do that? I can then factor out the cos theta on top. On the bottom of my fraction, I could actually use difference of two squares again. So this is going to be 1 plus sine theta, which is where this bottom thing here comes from, times 1 minus sine theta. That's just using difference of two squares to factorize the bottom. And then I can see that two of those factors are going to cancel out, and I'm just left with cos theta over 1 plus sine theta. Okay, so using difference of two squares is quite a good strategy, and it does often come up in these type of proof questions. I suppose the thing that would indicate to me that I knew that I needed to use difference of two squares was the fact that I had this 1 plus sine theta and 1 minus sine theta. That kind of looks like the factors that come out of difference of two squares. But that is a tricky one. All right, let's have a look at part C. I do find that with these questions, it's just a matter of practice, really. They do always seem, students do always struggle with them at first, but the more you do, you start to spot the sort of patterns that come up quite often and the sort of things they might have to do. Okay, so 1 over tan plus tan equals 1 over sine theta cos theta. Well, 1 over tan theta we discussed earlier, that would be cos theta over sine theta. So this is starting at the left-hand side here. Tan theta, we said that that was sine theta over cos theta. Okay, now let's try and add these fractions together. So I'm going to need a common denominator. So I'm going to make my denominator sine theta cos theta, which means that this one is going to become cos squared theta over sine theta cos theta, plus the other one is going to become sine squared theta over sine theta cos theta. Now if I combine these together, I'll get sine squared theta plus cos squared theta all over sine theta cos theta, and hopefully you've now spotted the top of this fraction will just become 1. There we go, that one was a bit nicer. Just got to make sure you're fluent with your adding algebraic fractions. So to get a common denominator, we can just times these two together. So that means that this one needs to be times by cos, and this one would need to be times by sine on top. So we get to here, and then we can simplify it from there. Let's have a look at the last one then, part D. Okay, so prove that 1 minus 2 sine squared divided by cos theta plus sine theta equals cos theta minus sine theta. Again, this thing here, cos theta minus sine theta, that looks like something that might have come out of difference of two squares, so I'm kind of expecting that to come up at some point. What I'm expecting is maybe I'll have like a cos plus sine times cos minus sine divided by something else where there's going to be some factors that cancel like I did last time. Okay. What I'm actually going to do here is I'm going to take this 1 and I'm going to expand that 1, which might feel a bit weird because if you haven't done much trigonometry before. But instead of 1, I'm going to make it sine squared plus cos squared. And I've still got the minus 2 sine squared theta, all divided by cos theta plus sine theta. Now on top I can collect the sine squareds together, so I'm going to end up with cos squared theta minus sine squared theta. This is looking promising for my difference of two squares. Okay. Then I can factorize the top using difference of two squares. Like that. And on the bottom I've got cos theta plus sine theta, and I can see that those factors on this one and this one are going to cancel out. So then I just get cos theta minus sine theta. That's my final answer. Okay, those four were quite tough ones. You might encounter ones that tough, you might not do, but it's better to show you difficult ones than show you easy ones. And this is a slightly different type of question here. So given that cos theta equals minus 3/5 and theta is reflex, find the value of sine theta. So what we can do to do this is we can use the identity sine squared theta plus cos squared theta equals 1 to help us. And what I'm going to do is substitute in the value of cos theta, because I've got to work out what sine theta is. So sine squared theta plus minus 3/5 squared equals 1. So sine squared theta is going to be 1 minus 3/5 squared, which is 9 over 25. So sine squared theta is 16 over 25, which would then mean sine theta is plus or minus 4/5 when I square root it. But how do we know which one it is? Okay, we're not really sure which one it is. Is it plus 4/5 or minus 4/5? I don't really know. Let's think about the information we've been given about theta being reflex. If we think about the cos graph, which looks like that, between 0 and 360, this is 180 here, a reflex angle is an angle that is bigger than 180. So we are looking in this zone here. It also says that cos theta is minus 3/5, so it's negative. So it's down here somewhere. Okay. If we now look at the graph of sine, okay, there's 180 there. And again, we know that the angle is reflex, so we're just looking in this zone here. Well, in that zone there, sine, the graph is only below 0, so sine must be negative. So it must be minus 4/5. Okay, so you do have to do that check of which sine is it. Okay, for part B, we're going to use the same sort of strategy. Let's just move this lower down. Okay, so sine alpha is 2/5 and alpha is obtuse. So again, we're going to use sine squared plus cos squared equals 1. So that means that 2/5 squared plus cos squared theta is 1. So cos squared theta is going to be 1 minus 2/5 squared. So that's 1 minus 4 over 25. So that's 21 over 25. Now when I square root it, I'm going to get a plus or minus root 21 over 5. Now I need to decide which one it is. So let's think about the graph of sine theta, which we were given first of all. And we were told that the angle was obtuse. And obtuse means that it's bigger than 90 but less than 180. So here's 90 and here's 180. So we are just looking at angles within this zone here between 90 and 180. Okay. And you can also see there that the sine graph is positive there, which agrees with sine alpha being 2/5. Now let's look at the cos graph. Okay. Let's put on some points. We are looking at the bit where it's obtuse, so between 90 and 180. Okay, so just looking in that zone there, and you can see the cos graph is negative there. So that means that cos theta must be minus root 21 over 5. Okay, so you can consider their graphs to help you. All right, to practice some questions similar to this, you've got two options. You can look at exercise 10C, which has got lots of similar questions to what we've done in. I've also got a separate worksheet here about doing some trig proofs, similar to the ones that we did earlier on. Okay, there's some questions there, and I've also got some work solutions on how to do those as well, because some of them are quite tricky.